Good morning, everyone, and welcome to this webinar hosted by MGIS. I'm Mike Darracott, Managing Director at MGIS, and I established this business over a decade ago to improve the way organizations think about spatial data quality. MGIS have evolved to have more of a focus on utility and infrastructure asset management and the role they increasingly play as custodians of our environment. Our mission is to build collaborative bridges between people, geospatial technology, sustainability, and productivity. A couple of housekeeping points to note. We're not expecting any interruptions or fire alarms during this session. We also welcome any questions, and you can offer these up in the available Q&A for us to respond to at the end, should any time remain within the allotted 30 minutes. There will also be a number of polls presented during the webinar, so please provide your responses, and this will help us understand any topics for future webinars or follow-up. So, to the topic of discussion, and the really important one which we need to be open and honest about: how we protect our buried infrastructure when faced with a spike or boom in construction. For me, history shows that we don't do enough in leaner times to ensure the correct foundations are in place with data and systems of planning and asset management. And that is why we often end up making the same mistakes. We need to improve. We need to utilize technology that enables risk to be reduced in a sustainable way. We all ultimately need to lay better foundations for future generations. I will be covering three specific aspects of navigating a way through these challenges, with a focus on our area of expertise here at MGIS, namely using GIS to improve data quality in asset management. Firstly, how will current and expected planning reform impact our buried infrastructure? Secondly, I'll look at some of the practical ways a modern GIS can reduce risk, support better decision making. And finally, how we can collectively ensure data integrity across an entire construction and asset lifecycle. Some of the numbers relating to the level of government and private sector investment in areas such as house building, utility infrastructure, and energy transition in the coming years are well documented. And these are very big numbers. They also represent some very big challenges and barriers to delivery. In order to meet the challenges, we need to see transformation and delivery at a rate not seen for many decades in the UK. When considering how new and imminent planning reform will impact buried infrastructure, I'm drawn to three distinct areas. 1, utility strikes and service disruption. 2, capacity strain, and 3, compounding vulnerabilities. Firstly, a construction boom driven by planning reforms increases the risk of damage to underground utilities during construction and maintenance activities. It's both a proportional risk, more excavations equals more strikes, and one caused by a lack of data consistency and quality. With capacity strain, reforms aimed at increasing housing targets and fast-tracking large-scale projects can place immense pressure on existing utility networks. This is particularly critical in areas already experiencing strains on water, wastewater, and energy infrastructure demands. And finally, with compounding vulnerabilities, urban growth can be a major contributing factor to infrastructure failure. This adds to existing vulnerabilities of buried infrastructure, which already face a combined risk from climate change, such as flooding events, industrial pollution, and in many cases, a legacy of inappropriate design for modern use and underinvestment. So using modern GIS tools that are cloud-enabled, accessible via web interfaces, plus geospatial data and relevant skills and expertise can help all project stakeholders visualize, analyze, and report in relation to all and any project constraints, reducing the risk of strikes during construction and bringing more confidence to decision making throughout a project. Firstly, I want to give a brief understanding of what is known as a connected network in GIS. A connected network in GIS refers to a system where all relevant enterprise and geospatial data sources are integrated and linked together within a single GIS platform. This allows for seamless data flow, analyses, and visualization across departments, across businesses, and across a geographically diverse stakeholder group, and enables a holistic and real-time view of all assets and operation activities. A connected network also refers to topology, where all the network nodes, assets, and customers are connected from utility source to meter point. This enables planned, unplanned, and emergency work to be communicated to all connected customers by running what is often known as a trace. And this helps with ensuring interruptions to supply and emergency response to unplanned outages are undertaken with minimum disruption. Identification and communication to vulnerable and priority customers is optimized within a truly connected GIS network. Dynamic constraints mapping and analysis enables the identification and visualization of limitations or regulations that impact planning and operations in real time. In the UK, there's now a mandatory requirement to minimize biodiversity loss on almost all construction projects. Using a biodiversity net gain tool in GIS, design teams can adjust and optimize construction footprints and boundaries to achieve minimum biodiversity net gain targets, producing real-time results as they go. Web GIS platforms can now be powered by interactive dashboards that provide visual summaries of key performance indicators and operational metrics. These dashboards, coupled with accurate reporting capabilities, allow for real-time situational awareness and support data-driven decision-making and performance evaluation to all project stakeholders. Real-time monitoring from space allows a connected GIS to integrate with real-time data feeds from sensors and satellite imagery, allowing for continuous monitoring of assets, environmental conditions, or other events such as third-party infringements remotely. This is crucial for applications like emergency response, asset and construction tracking, or environmental hazard management. Here at MGIS, we've seen a big demand for modern GIS tools and have been building off-the-shelf products and services that are now readily available either as an extension to an existing GIS platform such as ArcGIS Online, or as a hosted service feeding into an existing GIS or enterprise platform. In this last example, MGIS have developed an alert service which receives change detection evidence of third-party infringement centered on a specific area of interest on up to a daily frequency from satellites in orbit around the Earth. This is providing utility and infrastructure companies with risk alerts directly to a mobile application to ensure early intervention and avoid damage to critical infrastructure. So, to discuss how to ensure data integrity across the construction and asset lifecycle. This is crucial for safety, for efficiency, productivity, and project success. Data integrity refers to the accuracy, consistency, completeness, and reliability of data from its creation through its usage and eventual archival or destruction. To create a foundation for ensuring data integrity, we need to get serious about embracing GIS as a central component of digital transformation. Transitioning from traditional manual data management methods like spreadsheets to digital platforms and cloud-based solutions, fundamentally transforming project and asset management. We also need to ensure we implement robust data governance and management tools. When considering data validation and verification, we need to establish clear data entry and validation rules, employing systematic checks to prevent and detect errors at the point of data entry and during transfer. To ensure data consistency and ensure uniformity across different data sources and systems, this is particularly important for integrated platforms like GIS to prevent database discrepancies. In relation to data quality management, we need to regularly cleanse data by identifying and removing duplicates or outdated information to maintain data quality throughout the asset lifecycle. In summary, by strategically employing GIS throughout a construction and asset lifecycle, based on a thorough deployment of data integrity, organizations can significantly improve project success, reduce costs, and this is via more informed decision-making, reduced rework, and an optimized asset performance. We also need to emphasize the critical role of as-laid construction records and high-accuracy GIS field data capture in ensuring data integrity, especially when linked with GIS in the construction and asset lifecycle. While as-built records reflect the final state of a project, as-laid documentation specifically captures the precise location and attributes of concealed elements like underground utilities, pipes and cables, but also foundations or embedded structural components as they are installed. High accuracy GIS field data capture, utilizing technologies like GNSS RTK connected to mobile devices, ensures centimeter level precision in recording these vital details before they are backfilled or covered up. Accurate as-laid records readily available in a GIS are critical for future maintenance, repairs, and especially preventing costly damage during subsequent excavations or modifications. Knowing the exact spatial location of buried assets avoids guesswork and potential strikes. Investing in professional-grade GNSS receivers and specialized GIS field applications such as ArcGIS Online and Field Maps ensures that the collected as-laid data meets the highest accuracy standards required for critical infrastructure. Mobile GIS solutions enable real-time data capture and synchronization from the field to a central database, ensuring that the as-laid information is immediately available and constantly updated, reducing manual errors and data inconsistencies. High accuracy capture isn't just about location. It also involves collecting detailed attributes about these hidden assets. Pipe material, diameter, installation date, depth, condition. This all enriches the GIS database for better and future asset management. High accuracy as-laid data provides a precise foundation for creating and maintaining an accurate digital twin of infrastructure, allowing for realistic simulations, predictive maintenance, and optimized performance throughout the asset's life. Detailed as-laid records in GIS are essential for demonstrating compliance with regulations, safety standards, and environmental requirements, and also serve as crucial evidence in the case of a dispute or incident. With highly accurate as-laid data integrated into GIS, asset managers can make better informed decisions regarding maintenance scheduling, future development planning, and resource allocation, optimizing the entire asset lifecycle and maximizing value. In essence, High accuracy GIS field data capture for as-laid construction records ensures that the digital reality of what is built, especially what is hidden, is precisely documented, forming an indispensable cornerstone of data integrity and long-term asset management. So, to a recent and relevant case study, MGIS have been working with energy assets for a number of years now. Energy assets are a UK-based national multi-utility asset owner and construction business, and predominantly work on new developments. And this is particularly prevalent when we are potentially entering into an area where we've got to hit demanding housing targets, and companies like energy assets are at the forefront of delivering the buried services infrastructure and connections to all customers, residential and commercial. So what created and drove this forward was an initiative, now legislation, which is the National Underground Asset Register, a government-driven investment in creating a consolidated view of all the buried services and utilities that exist in the UK. So Energy Assets reached out to MGIS, and we looked at an end-to-end solution which would not only provide an enterprise GIS platform, in this case ArcGIS Online, but also a seamless end-to-end field to office high accuracy data capture solution. So Energy Assets were able to deploy high accuracy GNSS linked to a mobile device, running a GIS application that was capturing high accuracy data and information about the buried assets before they were backfilled on site. So they were able not only to capture the information, but validate it on site and submit it via the cloud seamlessly and directly to the asset record, thus creating a seamless approach and a vector-first approach to data capture and providing a robust method for updating the asset record and an asset lifecycle management tool across the whole business and its wider group of stakeholders. An important mention here is with regard to the next generation of geospatial technology, which is readily integratable with GIS applications in the field. What we're seeing here is a GNSS device, not on a pole, but it is able to capture precise centimeter level positions using a laser offset device. So not only can you capture information at speed, but you can also capture it safely at the side of an excavation. This is then validated in real time and submitted via the cloud to the GIS database in near real time. Something that MGIS are starting to demonstrate more, and I've got some upcoming workshops that will give you more information about shortly. MGIS has a collaborative role across a growing customer network. MGIS have been growing its customer footprint over the last decade and now see an opportunity to enable more joined up working and collaboration with GIS across the intersection between infrastructure asset owners, water, gas, telco, etc., those undertaking construction and maintenance on buried utility networks, and those environmental organizations responsible for preserving our natural and built heritage. So as a final point in this webinar, I'd like to thank you for attending this morning and taking the time out from your busy schedules. As a next step, we'd be delighted to discuss any aspect of your GIS or data quality journey with you, and can offer our insight, expertise, and a wide range of off-the-shelf and custom GIS products and services that can improve your ability to better serve your construction projects in an efficient and sustainable way. Please feel free to contact me or the MGIS sales team directly to have that conversation and unearth ways to relieve those data interoperability challenges and pain points. Thanks again for your time today.